This is the pre-lab video for the calibration of the volumetric pipette. For this video, you'll need a rubber bulb, a glass weighing bottle or vessel, several glass beakers, a burette stand, a thermometer, and a 10 milliliter volumetric pipette with the correct tolerance. Here's an example of the data table filled out for table 3. First step is to measure the initial mass of the vessel, so we tare the analytical balance such that all zeros appear in the display. Place the empty vessel with its cap on the scale and record all the digits that we see to the correct number of significant digits. The next part is to pipette the 10 milliliter sample in, so the next part is the technique to do so. To pipette the distilled water, you'll need the 10 milliliter volumetric pipette, distilled water in a 600 milliliter beaker, the thermometer from before, which you can now remove, 400 milliliter waste beaker, the weighing vessel, and some Kim white, as well as the rubber bulb. To begin, take the volumetric pipette, rotate the beaker such that the tip of the pipette is sitting right in the near bottom part of the beaker towards you. Using your one hand, you want to hold the pipette up near the end. You want to take the rubber bulb, depress it, place it on the top. Switch your hands if you need to, and gently release your hand. And as I release my top hand, you should see the water level in the beaker or in the pipette rise up. Now, if you want to get a feel for this, you can squeeze and release your hand a few times to see the water level move up and down. If you raise the pipette off the bottom and squeeze and release your hand, you'll see that the water moves much faster. So if we keep it down near the front, we're looking at this calibration line. The goal is to bring the water up to that calibration line. Say there's no more ability here to squeeze the bulb, you can just replace the bulb with your index finger, press the bulb again, place it back on, just so it's resting gently, nice and clean on the top, and then open your hand again. So up it comes. Here it is. You'll want to make sure that the water level at least gets above the calibration line. And now what you're going to do is quickly remove the pipette bulb and replace this piece with your index finger. You can take the pipette bulb, you're done with that, and now you can lift the pipette out of the distilled water into the waste beaker. And you'll note that there's some water on the outside as well as there may be a drip. So now what we do is we wipe the pipette with the Kim wipe before we bring the line down to the calibration line. So now we want to line up the meniscus in the pipette with the calibration line. And to do that, we just gently twirl the pipette. And when you do that, you'll see drips coming out at the end, one drop at a time. And we do this until the meniscus of the water is level with the calibration line on the pipette. So you may have to bend down a little bit to see. When you're confident, you tap the inside part of the waste beaker, take your weighing vessel, bring the pipette over, and and release all the water that comes out. Now a volumetric pipette is calibrated such that it delivers the volume with some volume remaining, so we never blow that tip of water out of the bottom. We just let it come all the way down. One or two little drips. If there's a drip at the end, you just gently tap it on the inside part of the vessel you've transferred to. You'll see there's some volume here. You can place the pipette back in the distilled water beaker. Now you can place the cap on your vessel and weigh that. Now you'll want to weigh the mass of the vessel with the water on the analytical balance. On the same one you used before, record all the digits that you see and transfer that to your lab data table. Next is to make sure the calibration line on the thermometer is below the line for the distilled water. Record that temperature to the correct number of significant digits and transfer that number to your lab data table. From the chart, you can now determine the mass of water delivered as the difference between those two numbers. From the density table in the lab, you can get the density at the temperature you measured and place that number in your lab data table. And now you calculate the density, the actual delivered volume by taking the mass of the water divided by the density of the water, plug in your numbers, and solve to the correct number of significant figures and place that number on your lab data table. That ends the video for the pipetting portion.